All right, here we go. Reference angle. Now this is sort of like the concrete sequential way of finding reference angles, but I want you to understand what we're trying to accomplish here. What we're trying to accomplish with reference angles is we're trying to figure out, we want to make it so that we only have to know the angles in the first quadrant. So when we talk about our unit circle, right? So we have our circle, that's not a circle. So when we have our circle, and we talk about the x and the y axes, this first quadrant is really the most important one. If we know the values of these points on the unit circle in the first quadrant, so this is 1, 0, this one's root 3 over 2 comma 1/2. This one's root 2 over 2 comma root 2 over 2. This one's 1/2 comma root 3 over 2. And this one is 0, 1. And I showed you the trick earlier about like it being root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2 to find these values. How do I know which one is the x-coordinate and which one is the y-coordinate in each of these angles? I think about the size of the angle. For a smaller angle like pi over 6, pi divided by 6 is a smaller number than pi divided by 3. So pi divided by 6 is a smaller angle, which means I'm going to be further to the right than I am up. And since root 3 over 2 is bigger than the 1/2, that's how I knew this was root 3 over 2 and this was 1/2. Here, it's the same in the x and y direction, so they're both the same value. That's root 2 over 2 and root 2 over 2. And then in this one, I'm not as far to the right as I am up. And so that's how I know that this one's 1/2 and this one's root 3 over 2. But once you know these values in the first quadrant, the idea behind reference angles is if you can know which angle that is in your quadrant. So let's say I'm here, okay? And let's say, since we know this is pi over 6, right? This is 1 pi over 6 past pi, which starting here and going all the way around, this is pi plus another pi over 6 gives me 7 pi over 6 as an angle. But in my head, I'm not thinking of this as 7 pi over 6. I'm just thinking of it as pi over 6 in the third quadrant, which in the third quadrant, any of my points should have a negative x and a negative y value. So I can still use these values. They're just going to be negative. So this is going to be negative root 3 over 2, negative 1/2. That's this point right here. If we're talking about 7 pi over 6, that's this same angle. I'm referencing back the angle that was in the first quadrant to find the values in my other quadrants. That's what reference angles are about. And you can use this formula. So you can see if I'm in the third quadrant, I want to do the angle minus pi. And that's sort of what I did here. I did 7 pi over 6 minus pi, which is 6 pi over 6. And that gives me 1 pi over 6. That's my reference angle. Okay? But it's always, the reference angle is always just the distance from the x-axis. So like if I had an angle here, this is the angle, this is the reference angle that I'm interested in. So let's say this was pi over 3. Then I can just say, oh, well, I know what the values are, except the x-coordinate will be negative and the y-coordinate will be positive, because I'm in the second quadrant. So let's put this to work, okay? For angles that aren't part of our unit circle, we can still use reference angles. I just have to know like where I am. So 3 pi over 5. So I know my first quadrant ends at pi over 2. Okay? And 3 divided by 5 is bigger than 1/2. And so I'm in the second quadrant. And so I would take pi and I would subtract the angle from it. And pi I'm going to write as 5 pi over 5. And so this is really the reference angle is 2 pi over 5. this is the angle I would reference. Now, this is not one of the angles that I know the values for by heart because it's not on my unit circle diagram. And so if I'm doing this anyway, I'm probably just going to use my calculator to find the value if I was looking for sine or cosine of this angle. But being able to find this reference angle and thinking in fractions of pi is going to be a really helpful skill. And for something like this, 5.75, this is clearly in the fourth quadrant because 2 pi is 6.28. So I would take 2 pi and I would subtract 5.75 from it. And I'm just using my calculator for this. So 2 pi minus 5.75, and that's just going to give me 0.533. So this would be my reference angle. And again, the reference angle is just the bigger picture here is being able to do what we talked about here, which is know which angle in the first quadrant we're referencing when talking about an angle in another quadrant. So that is reference angles for you. Let's use it to find the value here. So here we're talking about 59 pi over 6. Okay, so the way that I actually think about this, which is, it might seem crazy, but so 59 pi over 6 is really close to 60 pi over 6. And why did I choose 60? Because 60 divided by 6 is 10 pi. So this is pi over 6 short of 10 pi. Now, since 10 pi is evenly divisible by 2, and it takes 2 pi to get around a circle, what we've done is we're essentially going, here's 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. So we're actually back here where we started, but that's 60 pi over 6. We're 59 pi over 6, so we're pi over 6 short of that. So the angle is actually this one here is pi over 6. We're pi over 6 short of that. So the reference angle is pi over 6. And so the x-coordinate here is the same as what it would be here in the first quadrant. Whatever this angle would be in the first quadrant is pi over 6. And we're further to the right, so that's root 3 over 2, 1/2. But we're in the fourth quadrant. So here it's still root 3 over 2, but the y-coordinate should be negative in the fourth quadrant. So this is negative 1/2. And so now let's look at the actual trig function they're asking about. So this is secant, which is 1 over cosine. And the definition of secant of an angle is going to be whatever the radius is divided by the x-coordinate. Okay, well, I know the x-coordinate. There it is. It's root 3 over 2. Now I just need to find what the radius is. So the radius is the square root of root 3 over 2 squared plus negative 1/2 squared. And so this is 3 over 4 plus 1 over 4, which gives me 1. Okay. So the square root of 1 is 1. So this is a unit circle. But I can't just assume that it's going to be a unit circle all the time. Okay? I guess when you're finding the value and they're given the angle, the ratio is always going to come out the same whether or not it's a unit circle or not. So you don't have to go through this every time that we're doing a problem where I give you the angle. But if I said here secant of theta is equal to this and now find other trig functions, you would want to do this step. So I just don't want you to forget about that in this case. So we found the answer. Here it is. It's 1 over root 3 over 2. And so that's just 2 over root 3, which is 2 root 3 over 3. So that's my answer. So the last thing that I just want to talk about in this video, since this is the last slide really in the PowerPoint, Oh. I guess not. We have one more problem. Okay. So this time we have 17 pi over 6. Now the closest angle that gives me a whole number, again, 17 pi over 6 is really close to 18 pi over 6, which is 3 pi. But I have to be careful with this one, because when I think about my circle going around, right, we have 2 pi and then another pi actually brings me over here into the second quadrant, or the negative x-axis. And again, I'm pi over 6 short of 3 pi. So it's this angle right here. This is the pi over 6. Since I'm in the second quadrant, my x is going to be negative and my y is going to be positive. So my x coordinate is going to be negative root 3 over 2, and my y coordinate is going to be 1/2. And so the ratio here of x over y is going to be negative root 3 over 2 divided by 1/2. These cancel, and so the answer here is just negative root 3. I'm just putting this out here now just to plant a seed, but these are sort of the things you should think about when you're thinking about tangent or cotangent or cosecant or secant. And this is how I'm thinking about it in my mind. I don't think of it as y over x. I think of it as sine over cosine. It doesn't matter if you're thinking of it as y over x or sine over cosine. But I think in my mind, if I just know what the definition of sine and cosine are, sine being y over r and cosine being x over r, then I can find all the rest of these trig function definitions just by using those two definitions. Same thing here. I would memorize this one coming up. Not yet. You don't need to know this yet. But and then these other two just come right from it. So if I divide this by cosine squared of t, then cosine divided by cosine is 1. Sine divided by cosine is tangent. And then 1 divided by cosine squared is secant squared. And so dividing by cosine squared gives you this one. Dividing this whole thing by sine squared will give you this one. All right, but just planting that seed now, you don't need that information right now. So please email me if you have any questions, or if you're just not able to access any of these videos. But if you're not able to access them, then you didn't know that I said this. But just email me with any questions that you have. Don't forget to do the problem set associated with this, which is in class is problem set number 12. And that's going to be due on Blackboard. You're going to have to submit some work. So you can either do that on a separate piece of paper and take a picture of it, or if you have some sort of PDF marking up software in a tablet, you can do it right on the tablet and submit that. It's totally up to you, whatever